Chapter 8 test review. The Chapter 8 test will consist of circles, area, and volume. We're going to start with a review of circles. If you take a look, a circle is made when a center point is equidistant to points around the shape, and the difference between the radius and the diameter is that the radius starts at the center and extends to any one of the points. I could have had the radius going up, left, down, right, in any direction. The diameter, however, goes all the way across the circle through the center. So the diameter is twice the length of the radius. So if I knew that the radius was 6 inches, the diameter would be 6 inches plus 6 inches, or 6 inches times 2, so the diameter would be 12 inches. What if the diameter, the total distance, was 8 feet? Then the radius would be half of that. So the radius would be 4 feet. That was a mini lesson on radius and diameter because you need to know about them when you're doing area and circumference problems. So this is the type of problem that you might see on your test that could be confusing. If you're asked to get the distance around a circle, that's the circumference. That's why I always think of it as a circle fence, because you put a fence around your property. Circumference is the distance around a circle. So if I want to get circumference, I have to use the following formula. Circumference equals pi multiplied by the diameter. This is where our little mini lesson is going to be so helpful, because if I look at the circle, I see a 12 feet. But if you remember from the last little mini lesson, that 12 feet is the distance from the center of the circle to the edge. So that doesn't represent the diameter, that represents the radius. So when I'm doing my substitution, I'm not going to use the 12 feet. I'm going to use 24 because the distance all the way across the circle would be another 12, and 12 plus 12, or 12 times 2, is 24. Then I multiply, pi is always 3.14, 3.14 times 24, and I'll get 75.36 feet. Since circumference is just measuring a one-dimensional distance, okay, a length, you just write feet. It's just a linear unit. It's just feet with no exponents or anything like that. What if this had been an area problem? Notice I kept the circle the same, but this time I changed our keywords. If you need to cover the inside of a circle, then you need to find its area. And one of the things that you must have noticed by now is that whether you're doing area, circumference, volume, you need to make sure you're using the right formula. So we look at our formula sheet and we see that area equals pi times radius squared. There's some good news. This time we have the radius already given to us, so I don't need to figure anything out, okay? If they had given me the diameter, I would have divided by 2, but this is the radius. Now, if you notice, I put 3 parentheses here. Why did I put 3 parentheses here? Because the pi is going to be the 3.14, and radius squared means I'm multiplying by 12 squared, or 12 times 12. And I would get 452.16 square feet. Notice because it's area, I'm now using the square units. So that is circles. If you are asked to get the circumference or the distance around the circle, you use C equals pi times diameter. If you're asked to get the area or to cover the inside of the two-dimensional circle, then you use pi times radius squared, and you label your answer in square units. That's circles. Let's move on to area of composite figures. If you're doing an area of a composite figures problem or an area of a shaded region problem, you're going to need to make sure that you are identifying what two-dimensional shapes you see and the correct formula to use for them. If it's composite figures, you'll find what 2 shapes or 3 shapes you see, get the area of each, and add them. If it's a shaded region problem, you'll get the area of the whole shape, Subtract the unshaded part, and you'll be left with the shaded region. These are the different shapes that you should expect to see on your test and be prepared for. If it's a square, all the sides of, or it's a four-sided figure where all the sides are the same, and to get the area, you just do side squared. So if the side was 3 feet, it would be 3 times 3, or 9 square feet. Rectangle is length times width. You multiply the two sides together. A triangle is 1/2, it's a three-sided figure. 1/2 the base times the height. Make sure when you're looking for the base and the height that they make a 90-degree right angle. This long side here would not be a measurement that you would need. Parallelogram, again, is base times height. You're looking for that 90-degree. A trapezoid, 1/2 multiplied by the height multiplied by base 1 plus base 2. So you add up the length of the bottom and the length of the top, and you multiply that by 1/2 of the height. And then a semicircle is just the same formula for area of a circle, only since it's half the size of a circle, you divide by 2 at the end, because that'll give you half. So these forms, you should copy these down. Okay, pause this slide or print out the paper that I attached to the assignment and have that out with you during the test. So these are the formulas that you need. Now let's look at an example of a composite figure. So let's take a look at this house. Okay, what two shapes do we see? You should see a triangle and a rectangle. So I gave myself 3 boxes to work with. Why 3? Because I'm going to get the area of the triangle, I'm going to get the area of the rectangle, and I'm going to add them up to get the total area of the composite figure. If you notice, look at all of the work I was able to do without even plugging in the numbers yet. I wrote my formulas down, I set up some parentheses, I wrote some labels in, I even have my addition sign at the bottom ready to go. Now it's just a matter of looking at the picture. The easy one is the rectangle. The rectangle is clearly 14 feet by 8 feet. So I can substitute those numbers in, piece of cake. The triangle is a little trickier because none of the sides are labeled. So I have to use the rectangle to help me. How can it help me? Well, I know that if I'm looking for the base and the height, they need to make a 90-degree right angle. So if you noticed, I drew in the B across the bottom of the triangle and the H going up. The B is right here. If it's a rectangle, right, then the opposite side should be the same measurement. So the B is going to be the 8. So 1/2 times 8. The tricky part is the height. The height's not measured. Is the height 20? Think about it very carefully. No. 20 is the distance all the way from the bottom of the house to the top of the roof. What do we know? We know that the rectangle part's 14. So if the total distance is 20 and up to here is 14, what's left to be this distance right here that when you add it to 14 would get 20? It would have to be 6, yes, because 14 plus 6 gives us the 20. So it's 1/2 of 8, which is 4. 4 times 6 is 24. So now it's 24 square feet plus 112 square feet. I add them up and I get, I'll do a little quick mental math, 136 square feet. I added up the area of the triangle and the area of the rectangle, and I got the area of the composite figure. Here's an example of a shaded region problem. You have a large triangle with a shaded section. If you want to get just the shaded part, you get the area of the whole triangle, 1/2 base times height. The base and the height are the 8 and the 14. So the whole triangle is 56 square inches. Then you get the area of the small triangle, which is 4 by 6. So 1/2 times 4 times 6, which would be 12 square inches. And then you take the total area minus the unshaded piece, and what you'll be left with is the shaded piece is 44 square inches. That's how you do a shaded region problem. Get the area of the whole thing, subtract the part that you don't want to know, and what you'll be left with is the shaded piece. And finally, volume. Volume of prisms. We have triangular prism, we have rectangular prism. If you notice, what do they have in common? For both prisms, you get the area of the base and multiply by the height, or by how long it's extended. In the formula for triangular prism, it's a capital B, and then inside the parentheses to represent that capital B, you're getting the area of that triangle in front. 1/2 base times height. 1/2 times 4 times 7. The area of that triangle, if we do some mental math, half of 4 is 2. 2 times 7 is 14. So that triangle is 14 square inches, but it's been extended 10 times. So I multiply by 10 and I'll get 140 cubic inches. Rectangular prism, I get the area of the base again, only this time that letter B is replaced by length times width. Why? Because what's the area of a rectangle? Length times width. It's the same idea. What they have in common is you get the area of the base and multiply by the height. So the base is 12 times 3, that's 36. Multiplied by how high it is, it's been stacked 5 meters, and you get 180 cubic meters. I got the area of the bases, and then I multiplied by the height. That's what they have in common. What do they have different? They have different bases. This one has a triangle, and this one has a rectangle. So that is chapter 8. That's what you need to know. Circles, circumference, area, radius, diameter, area of composite figures, area of shaded regions, and then volume of prisms. I hope you all try the journal, even though it's optional. I think it'd be great practice. And if you do well, you can boost your grade. And there's going to be a Google Meet at 1:30 on Wednesday. So you're definitely going to want to check that out. If you have any questions, you can always email me. The test is on Thursday. If you're trying to hand in late assignments, they have to be handed in by Monday at 3 p.m. And good luck, everybody. Let's end strong. Make sure you're prepared. Make sure you have notes out when you take the test, okay? Have all those formulas out, have examples out. Everything that I showed you in this 12-minute video, have that out in front of you so that you can use it to reference. Good luck, everybody.